Welcome to Getting Connected, a video overview of how to allow outside users to connect to your Rumpus server. In the next few minutes, I'll show you how to set up your server's TCP/IP access and demonstrate how to enable connectivity to your server on a typical router. Before we get started, it's important to understand what's really going on. Think about a computer network the same way you might think about the phone system in a typical office. In an office, there might be lots of people with phones on their desks, all of whom can make outbound calls whenever they like. When someone from the outside world calls the office, they dial the one phone number shared by the entire office, and a receptionist answers the phone, asks who the person is trying to reach, and directs the call to the correct extension. Most modern networks work in exactly the same way. Any computer on the network can make outbound connections, all of which are routed through the shared internet connection. And when someone from the outside world makes a connection to your LAN, some process is needed to direct them to your Rumpus server. In this analogy, your router is the receptionist, and what we'll be doing is telling the router which computer on your network should receive incoming calls. To start, you'll need to open a control session on your router. Most modern routers are controlled using a web interface, so I'll start Safari and then connect to my router's local IP address. The router I'm using in this test is set to use port 8001 for its web administration, so I'll include the port number too. If you have questions about managing your own router, see the documentation that came with it or was given to you by your ISP. There are hundreds of different routers on the market, each of which uses a slightly different interface for managing configuration. Setting up your router will most likely be a little different from the following demonstration, but the basic task is usually very similar. One task your router probably performs is assigning local IP addresses for computers on the local network. This process is called DHCP and allows computers on the LAN to configure themselves with the help of the router. Using DHCP, each computer on the LAN is dynamically assigned an address from an available pool of addresses managed by the router. In an office, if the telephone extensions to each desk were always changing, it would be impossible for a receptionist to reach people reliably. The same goes for your LAN, so the first thing you'll need to do is make sure that your Rumpus server's local IP address never changes. If we check the DHCP settings for the router on my test network, we see that the pool of addresses used is 192.168.1.50 to 192.168.1.99. We'll need to choose an IP address outside of that pool for the server to avoid conflicting with addresses assigned by the server. If necessary, change the DHCP address range on your router to make sure that there is a static address available for your Rumpus server. To configure the server with a static address, open the Network System Preferences panel. TCP/IP should be configured either manually or by DHCP with a manual address. In this example, we'll choose DHCP with a manual address, so that DHCP will take care of everything except the address, and I'll choose 192.168.1.201 for the server. Again, this is only an example. As long as your server has a static and unique address on the LAN, you're ready to move on to the next step. If your Rumpus server is the only computer on your network that outside users need to access, the easiest option is to have your router forward all inbound connections to your Rumpus server. On my Netopia router, this is called IP maps, but it's also commonly called NAT, or Network Address Translation. I'll add an IP map and choose a name that will be easy to recognize, in this case, Server Forwarding. Next, I'll enter the static local address assigned to my Rumpus server. In this case, I'll also enter the external IP address that should be routed, since there are several addresses assigned to my LAN. In most cases, though, where you've been assigned only one IP address by your ISP, supplying the external address may not be necessary. Once you've configured the router to send all inbound requests to the Rumpus server's local address, you can simply restart the router for the change to take effect. Have someone from outside your network try to access your Rumpus server using a web browser or FTP client by connecting to your external network address. Once you've confirmed that outside users can connect, the job is done, and your server is ready to handle file transfers for anyone on the internet. If you have other computers on your LAN that outside users may need to connect to for any reason, or if you prefer to allow only the specific ports needed for Rumpus access, the setup is a little more involved. Configuring specific ports for routing is usually called port mapping, port forwarding, virtual servers, or in this case, pinholes. To add my first pinhole entry, I'll click the Add button. It's usually best to start by setting up web access, since the web protocol is simpler from a networking perspective than FTP. So I'll give this first entry a name of WFM forwarding. Both web and FTP use only the TCP protocol, so the other protocol options can safely be ignored. This router allows me to specify a range of ports to be forwarded, but for right now the web server port 80 is the only port I need. Next, I'll supply my server's static IP address on the private LAN, and then the Rumpus web server port number as the private TCP port. In all port mapping setup, it's usually best to have the public port number and the private port number be the same for simplicity. In this case, for example, outside users will be making connections to my router on the web default port of 80, and those connections will be routed back to the Rumpus server on that same port. With the port mapping configured, restart the router and then have someone from outside your LAN start a web browser and attempt to connect to your public IP address. When they do, they should be presented with the Rumpus login page, just as you are when connecting to your Rumpus server from inside your network. If outside users still can't connect, review your settings and, if needed, send email to Maxim Technical Support for help. To allow FTP access to your server, create additional port mapping entries for the needed FTP ports. By default, these are 21 and the range 3000 through 3008. Be sure to check the Network Setup window in Rumpus for a complete list of the ports that need to be mapped based on your Rumpus settings. Different routers handle defining port mapping ranges in different ways, so be sure that each port maps straight through to the same port on the local network. In other words, regardless of how your router handled the creation of port mappings, make sure that port 21 maps to port 21 on your internal IP address, port 3000 maps to the internal port 3000, 3001 to 3001, and so on. That's it. The router setup is complete, and once the router has been updated, outside users will be able to connect via either web or FTP. Note that some routers perform automatic FTP address translation while others don't. If outside users have trouble using FTP clients, be sure to open the Network Setup window in Rumpus and enter your external Internet IP address in the Network Address field. Many routers will handle this job automatically, and in fact may be confused when the server is configured to use the external address. In this case, the Network Address field needs to be left blank. As always, if you have trouble, or if you simply need someone from outside your LAN to test your setup, send mail to support@maxim.com. We'll be happy to help you make sure your server is publicly accessible and working perfectly.